When solving linear inequalities, we're not going to do anything different than we would if we were solving an equation, with the exception that's highlighted here in this set of instructions, that if we multiply or divide both sides by a negative, we're going to have to flip the inequality symbol. And that's just a shortcut for if we were moving things from one side of the equation to the other, they would end up on opposite sides of the inequality symbol. And so instead of having to move stuff by adding and subtracting, if we just divide everything by a negative, we're going to end up having to flip that inequality. So in this case here, if I want to solve for x, I'm going to need to multiply both sides by the reciprocal of that negative 7/9. So we don't divide by fractions, we always just multiply by the reciprocal. So I'm going to multiply both sides by negative 9/7. And so you'll notice that it's still negative. I'm not changing the positive negative sign of what I'm multiplying by, I'm just changing it to its reciprocal. So I'm going to multiply this side as well. So over here on the left, everything cancels out, so we just get x. I have to flip my inequality symbol, and so now over here on the right hand side, I've got a negative times a negative is going to equal a positive. I've got some cross canceling to do. The 7 goes, the 14 becomes a 2, the 9 goes, the 27 becomes a 3, and so in the end we end up with a x is less than 2/3 as our answer. And then of course we can go back and graph this on a number line as we did in one of our first days in the course together. So I can put 2/3 in the middle. I can count by whatever I want on the number line as long as I'm consistent. So I can go up by 1/3 in each going up, so that would make 1. I can go down by 1/3 in the opposite direction, that would give me 1/3. And then I can graph it with an open circle in this case because we're not equal to, and then less than is going to send me to the left. In the second example, we have what's called a compound or a combined inequality. And really what it means is we have two inequalities smashed together. So on the one hand, if I read it backwards, I've got 5x plus 1 is greater than negative 4. And then I can eliminate the other side of it, and we can see that we have 5x plus 1 is less than 19. So I could rewrite this as two separate inequalities and solve them independently, and then bring those two results together into one combined answer. Or I can solve them simultaneously. So I need to solve for x. To solve for x, I'm going to have to subtract 1. I have to undo my addition or subtraction. And so now I'm just going to subtract it from both sides of the problem. So I've got now 5x left in the middle. I haven't divided by a negative or multiplied by a negative, so my inequality symbols stay the same. So then on the left there, I've got negative 4 minus 1, negative 5. And then on the right hand side, 19 minus 1, we get 18. And then same idea, I'm going to divide by 5 to get rid of the 5 that's multiplying the x. And so I'm going to do that on both sides as well. So we end up with x. Over here on the right hand side, we've got 18/5. We'll just leave it like that. We can think of it as 3 3/5 if we want to think about it where it's going to fit on the number line. Over on the left hand side, we've got negative 1, and again we have our less than symbol there. And so if we wanted to refer to a number line again for this one, so here I can just put negative 1 over here on the left. I've got 18/5 over here on the right. And then again, there are no equal signs in either of these inequalities. So I'm going to have open circles at both of those. And then I'm going to include all of the numbers that are in between. Because what we're saying with this inequality symbol is that x has to be greater than negative 1. That's sending us this way. And at the same time, x has to be less than 18/5. So that's sending us this way. So we're just looking at the numbers that are in between those two boundary points.